Alright, for our segment, we did work and energy. You know, work hard, play hard. And first off, I want to start talking about work, which is the force times the distance. An example of that would be
shooting the basketball. The term force times distance describes something done to the object, the basketball, where an agent, the player, in the environment exerts a force that displaces the object an amount d. The work done on an object by external forces changes the amount of energy the object has. So, when 500 newtons of force from the player is used over 28.5 meters, the length of the upcoming full-court dribble run, 14,250 joules of work are exerted from the player in this simple exercise motion. And for the upcoming traveling layup, when a player travels 10 meters using 900 newtons of force to perform such an amazing feat, the player exerts about 9,000 joules of work.
next one is power, which is work over time. An example of that would be
shuttle runs, the sports conditioning activity where a player runs to a point and back, then to a further point and back, and finally to a further point and back. Power is the rate of doing work, which is the rate at which energy is transferred. Power varies largely on how much work is done. When dribbling a ball with 100 joules of work over 15 seconds across the court, that produces about 6.667 watts of power. Energy is described as the ability to produce change in itself or the environment. An example of this would be dribbling.
Dribbling undergoes energy transformation. However, its motion follows one-dimensional vertical path in most cases. The ball has a gravitational potential energy at the top of its path when it is not in motion. When a force is applied downward on the ball, its gravitational potential energy transforms its kinetic energy until it hits the ground. The kinetic energy turns into sound, thermal, and static electric energy until the force of the ball brings the ball back into the person's hand. Energy, work, and power principles apply to jump shooting. Starting off with gravitational potential energy, a shooter transforms that energy into kinetic energy prior to and after shooting. This is then turned into sound, thermal, and static electric energy as it's stopped by the net. Tension in the net is caused by the gravitational energy of the ball.
Our example of defense on the young boy shows energy and work put to its full potential to cause a major block. Finally, we have an example. A world-famous basketball player throws a basketball 9 meters in the air in 15 seconds by exerting an upward force of 1.2 times 10 to the 4th newtons. And we ask, what power does the player produce in watts? First, we draw our friendly diagram, which shows our player, our force, and our distance of 9 meters. Then we figure out our knowns, which are distance, 9 meters, time, 15 seconds, and force, 1.2 times 10 to the 4th newtons. Then we use our formulas to make calculations. And since we know work is equal to force times distance and power is equal to work over time, we know that power is equal to force times distance over time. And then we substitute in our knowns, and we have power is equal to 1.2 times 10 to the 4th times 9 meters all over 15 seconds to give us a final answer of 7,200 watts or 7.2 kilowatts.